Welcome to Pomodoro Joe for Sunday, January 29th, 2023. Today we'll be looking at LeetCode problem 460, LFU Cache. This is a hard problem. And essentially in this problem, we are given the LFU Cache class, and we need to implement three functions, the init, the get, and the put. So similar to an LRU cache, the LFU cache will keep track of the frequency of use of an element. Then when it reaches its capacity and you try to put a new element, it will remove the least frequently used element before inserting the new element into the cache. All right, a couple things to note here in the instructions that can help us out. So this says, to determine the least frequently used key, a use counter is maintained for each key in the cache. The key with the smallest use counter is the least frequently used key. So that's the first thing to note. Another thing to note, it says, when there is a tie, i.e. two or more keys with the same frequency, the least recently used key would be invalidated. So we not only have to keep track of the frequency, but within the frequency, we have to keep track of recency. One last thing to note is the functions get and put must each run in O of 1 average time complexity. Okay. There is a lot to unpack with this one. I will do my best to explain it as I go, but I'll be moving fast. Before I start the Pomodoro timer, I'll just go over what we need to implement. The init takes a capacity, the get takes a key and returns a value, and the put takes a key and a value and stores it in the cache. All right, there's a lot to cover with this one, so we'll just get started. And 25 minutes on the Pomodoro timer. Let's go. So we need to keep track of our capacity. And we also need to keep track of how many elements are actually in our cache so far. So we have a count. So capacity and a count. We will also need a key value store to actually store the elements in our cache. So I'll call this the cache map. And that's just going to be a dictionary for our key value store. The other things that we will need, we'll need to keep track of the frequency. So we'll have a key to frequency map. And for this, I will use a default dictionary. With the integer to keep track of our frequencies. The other thing we'll need is a frequency to keys plural, because you can have multiple keys with the same frequency. And for that, we will also use a default dictionary. But for this, what I really want is an ordered set. I want to be able to just grab elements from the frequencies. So basically, I want to find a list of all the keys for a particular frequency and be able to remove or replace them with an O of 1 operation. Unfortunately, a list is kind of what I want, but I can't remove things in O of 1, so I need an ordered dictionary. And the last thing I will need is the minimum frequency so far. And we'll set that to 1 to begin with, because that is the minimum frequency of any element. So these are all the pieces that we'll need. Okay, so for get, this is pretty easy. If the key is in our cache map, we will return it. But we'll have to do some updating of our frequency. So let's say if the key is not in our cache map, then we'll return -1. Otherwise, we need to do some update operation. I don't know what it is yet, but we'll just create a placeholder here. So we'll call update, and then we will return our value for the key. Okay. So that takes care of the get. Now we don't have this update key, but we'll create that in a minute. Now put, if the key is in our cache, we'll just replace. And then we will also update the frequencies and counts for this key. And we will return because we are done. Now, if the key is not already in, then this is a new key value. So for this, we need to check, do we have room? If the count is greater than or equal to the capacity, well, then we need to make some room. So we'll remove the least frequently used. And then if we have room, and so we'll say the cache map for this key is equal to our new value. We need to increment our count, and then we'll set our min frequency, because this is the first time we've put this element in. Then it has a frequency of 1, which means the min frequency gets reset to 1. Okay, so that should take care of our put. Now we need to implement our 2 helper functions. Okay, so this gives us our basic elements. These are not implemented yet, but I will implement them now. So updating our key. So basically we're just going to increment the count, or update the count, and then we'll update the frequencies. Okay, so updating the count. So the old count is going to be equal to our keys to frequency, or key to frequency at this key. And so the new count, it's just going to be the old count plus 1. So basically we're just saying anytime this key is accessed, either with a put or a get, we'll just increment the count by 1. It's been used. Okay, now I have to update the frequencies. All right. So if the old count is not 0, then we need to remove this count from the old count frequency. So basically you have to say delete. So we have a frequency to keys for this old count. And that's going to be some default dictionary. Oh, sorry, that is going to be an ordered dictionary. So we need to remove that key from that ordered dictionary. And then self frequency to counts, or to keys for the new count. We'll just create a new key, and the value doesn't really matter, so we'll just throw none in there. So essentially, I just need a way to store a bunch of keys, and I need them to be ordered, and I need them to be O of 1 accessible. The ordered dictionary makes the keys instantly accessible with O of 1 runtime. The value doesn't really matter. What I really want is an ordered set. I don't need the dictionary, but there is no ordered set in Python, so an ordered dictionary is the closest thing I can get. Okay, so now that we've updated the frequency, there's one last piece. So what happens if when we remove this key here from the frequency, if that's empty, then we can just remove that frequency altogether. The other thing we'll want to do here, if this old count, this old frequency was the min frequency, so if our self min frequency was equal to this old count, well, now we no longer have anything at that frequency. So this new min frequency is we need to update this to our new frequency. Okay, so that updates our key. We update the count and we update the frequency. Next, remove the least frequently used. Okay, well first, we'll just make sure that we have something in our least frequently used. So if it's not in there, well, we'll print like error, something went wrong here, and we'll return. Otherwise, we need to get the LFU item from our min frequency. So this is going to be some ordered dictionary. Let's see, I want to say the item is equal to this ordered dictionary, and we'll actually pop item. That's the interface into an ordered dictionary. You can pop the item. So that'll return the key value for the first element that was put into this dictionary. All right. And so from that, we need to get the index or key, and that's going to be the LFU item at index 0. The value will be at index 1. Okay, now that we have this key, we need to remove the item from the cache. So we'll remove the item from the cache. We also want to remove the counts. And since we've removed an item from the cache, we will decrement our count by 1. And then do any cleanup. So for this, if we've removed the last element from our frequency to keys, then we'll just remove that whole key altogether. All right. Okay, I think that should do it. And I probably have a ton of typos, but we'll give it a shot. At this point, it didn't pass because I had some typos. So I fixed the typos, ran again. It still didn't pass. I clearly had missed something. So I went back, looked through the code. It turns out I had missed one line that I had completely forgot to put in. I couldn't find it. It took me forever just searching, trying to figure out what was going on. I put some debug prints in. Clearly, this was not my day. So, Pomodoro timer triggered. I took my 5-minute break. Then I came back with a fresh mind, clear head, was able to look through this quickly, find my error, fix the one spot in the code that I missed. It was an update to the keys. And once I got that fixed, I was able to run again, remove all my print statements, and finally submit the code for review. When I add this key, I need to update it. There we go. Silly things like I overlooked updating the key. Okay, let's give that a shot. All right, we pass. It took some debugging, but we did it. Okay, so this beats 61% of other algorithms for runtime, and it beats 36% for memory. There are ways to optimize this, but I am out of time, so that's where I'm going to leave it today. Hope you enjoyed this. Hope you learned something. Thanks for bearing with me on this one. It's a hard problem. All right. Once again, hope you enjoyed this. Hope you had fun. Hope you learned something. Please write better code.